Alright, so another thing that I noticed we had some difficulty with on the test was solving exponential equations with unlike bases. Okay, so remember, the exponents will only be equal if the bases are equal. So in other words, right, we know in an instance like this, 5 to the x equals 5 to the fourth power, you know that x has to be equal to 4 so that these are equal to one another, so that 5 to the fourth power equals 5 to the fourth power. So in order to solve an equation with exponents when we don't have the same base, we need to first find the same base. So for example, we're looking at this problem, 4 to the power of x equals 256. Now, always a good starting point would be to see if one of these numbers can be our base. So for example, we want to see if 4 could be a base for 256. So we know that 4 squared would be 16, 4 to the third power would be 64, and in fact 4 to the fourth power, right, 64 times 4 would be equal to 256. So in this case, we can use a base of 4. So here we have 4 to the power of x equals, we just showed that 256 is 4 to the fourth power. Now that we have the same base, we can just set our exponents equal to one another, and we get x equals 4. Looking at another example, this time we have 9 to the power of 2x equals 3 to the power of x minus 6. So once again, we're going to start with our smaller number and just see if that could be a base for our problem here. So in this case, we have 3. So let's see, can 3 be a base for 9? Well, yes, we know that 3 squared equals 9. So the first step, go ahead and in parentheses replace 9 with 3 squared. And then we know that we'll have 3 squared to the power of 2x. And that's equal to 3 to the power of x minus 6. Now we know that 3 squared to the power of 2x would be 3 to the power of 4x, and that's equal to 3 to the power of x minus 6. So we have 4x equals x minus 6. We can subtract x. So 3x equals negative 6. We can divide by 3, and we get x equals negative 2. Okay, so for this next one, we've got 4 to the power of 3x equals 8 to the power of x plus 1. Now again, we can always start with our smaller number and see if that would work as our base. But we'll notice pretty quickly we cannot use 4 as our base because 4 squared is 16, which is already larger than 8. So instead, we need to go smaller. So we can see if 2 works. Well, we know that 2 squared is 4, and 2 to the third power is 8. So we can replace both of these with a base of 2. So 4 becomes 2 squared, and that's to the power of 3x. And 8 becomes 2 to the third power, and that's to the power of x plus 1. So now 2 squared to the power of 3x would be 2 to the power of 6x. 2 cubed to the power of x plus 1 would be 2 to the power of 3x plus 3. So now we can say 6x equals 3x plus 3. Subtract 3x from both sides. 3x equals 3. So x is equal to 1. Okay, and finally we can look at one with a fraction as our base. So these ones are a little bit trickier. But again, we want to see if we can find a common base. Now, I always like to just start, if I have a fraction here, I'm just going to start by looking at the denominator of my fraction. Okay, and see if I can use that denominator to have a common base with my other side. So on the other side of the equation, I have 27. And for me, I can see a connection between 3 and 27, because I know that 3 to the third power is 27. So if I can rewrite 1/3 as having a base of 3, and I can rewrite 27 as having a base of 3, then I could rewrite this and solve for the exponents. So if I have 1/3, I could go ahead and start by rewriting that as 1 over 3 to the first power, because 3 to the first power is simply 3. Okay, and if I know my negative exponents, right, 3 to the negative 1 power just means the reciprocal of 1 over 3 to the first power, right? Just like if I had 3 to the negative third power, that would mean 1 over 3 to the third power, right? So that negative exponent just means the reciprocal of that normal power. So I have 3 to the negative first power, which represents 1 over 3. So now I have a base of 3 here. And on the right side, I can have a base of 3 as well. 3 to the third power. That gives me 3 to the negative x plus 1 equals 3 to the third. So negative x plus 1 equals 3. If we subtract 1 from both sides, negative x equals 2. So positive x equals negative 2.